In real life, when you go to the store and you say, how much does something cost? A shirt. The storekeeper doesn't say, the shirt costs half of pants plus shoes, right? The storekeeper will say, and you don't have to copy this, the shirt equals, I don't know, $25. Right? So you're always trying to find details on a piece, I know how to spell, of information in your life, right? Whatever it is. How much does gas cost? Gas cost $2.19 a gallon. Okay. Think of a variable as that detail as you're solving things. When you were little and you were doing your math facts, the detail was the answer. What's 2 times 3? 2 times 3 is something. In order to find out the details, you have to extrapolate using a variety of methods. And what you've learned throughout the last couple of years is how to do that. And what you're going to see today, I promise you, is nothing new to you. So please look at this with me. Practice these with me. Don't forget what you've learned. Here's my example 1. 20 added to 7 times what is equal to 9 times the same what. Since it's the same variable, obviously it's the same what. Your goal always needs to be variable 1 variable equals a number, right? Some variable equals a number, 1 of that variable. And to do that, you gradually have to change or rewrite the equation until you get to that spot. Right now, I have 20 plus 7 of them is 9 of them. So my first step is going to be collecting my thems, my variables, on one side. Collecting like terms. You guys remember that, right? So back to my shirt argument. 20 is equal to 2 shirts. I don't know. If I were using this goofy shirt scenario. Well, I don't want to know what 2 shirts cost, so to speak. I want to know what one of them is. Solve for one of them. To do that, if I know 2 of them is 20, then by cutting it in half, I find out what one of them's value is. And that's where you end up with your final answer of what the variable x is. Now it doesn't matter where everything appears. Just know that if things are across from each other, as in on opposite sides of the equal sign, in order to combine them, you either need to add or subtract based on the sign of the coefficient. By the way, what is the sign of the coefficient 9? Positive. So if you needed to move that to the left, you'd have to subtract it, right? Okay, let's do another one. Okay, solving for the variable t. I need to collect all my like terms on the left. Why am I choosing the left, by the way? Why don't I just move this to the right? Because really, you have the option. Any ideas, Lee? Why do you think you should move the 6 to the left versus move the 4 to the right? Already by itself. So this is variable only. This is variable and number. When you can, simplify it by making it one type of thing on one side, one type of thing on the other side, just as quickly as possible. 10t equals 50. I don't care what 10t is, I want to know what one of them is. Now let me show you what I kind of was just bringing up with Lee here a minute ago. 4t is equal to 50 minus 6t. You know, there's always a couple of ways to get places. We tend to like to take the easiest route. What if you did subtract 4t? I now have 0 is equal to 50 minus 6t. Well, I want to have variables on one side and numbers on the other. What do you want to do? We can still work this. You want to subtract 50 or add 6t? Yeah, sorry. Thank you, ma'am. So we can either subtract 50 or add 10. What do you want to do? Sure, we can subtract 50. We're running out of room. Negative 50 is equal to negative 10. Now what? Divide by negative 10t. By negative 10, I mean. T is equal to 5. Did we end up with the same answer? A little more work, though, don't you think? But if that's how your mind thinks, if your mind went there before it went here, you'll still be able to get there. You just need to work it and take your time getting there. Okay? That's example 2. The rest of this entire lesson is all of the same, only a bit more complex maneuvers. You know, in aircraft, or in the Air Force, they call flying movements maneuvers, and the goal is to get somewhere a certain way. I'm clearly no expert in that world, but, whoops, hold on, don't copy that. That should have been a 3. 3/5 x is equivalent to 4 minus 8/5 x. Okay? Variable on one side, on the right, variable and number. Based on the last one, Jay, what do you think would be the quickest way to get where we want to go? Okay, so add the 8/5 x. Yep. The result is going to be 11/5 x being equal to, is that a 4? Yes. Now you might look at that and say, well, this just doesn't look like something that's going to solve very cleanly, and it might not solve cleanly. Yep.
Would that be a negative 8/5 x?
This was a negative 8/5 x because of that negative sign. Great question. So 4 minus 8/5 x means that this is a negative. So in order to maneuver it, adding it is the opposite. Great question. So the opposite sign of the coefficient was negative, we added it. What do we do now? Any ideas? What that does on the left is causes you now to only have 1x. What that does on the right is causes this. And you're done. This next item from here tends to cause a lot of problems. So if you are feeling super, super confident up to this point, please take a gander at this one, okay? You have a division problem going on here, And the result of all of that division and then this subtraction is y. But we need to get to a place where we have y is a number, or a number is y. So what you might not remember from your order of operations is you've got to deal with your grouping symbols first. Grouping symbols first. So this division bar is a grouping symbol, which means I need to deal with the division of 2 before I can deal with the difference of 6 and 4y. And how do I deal with division? Multiply it. Multiply by 2. The 2's disappear, leaving me with 6 minus 4y is equal to 2y. So far, so good? Add 4y, add 4y, 6 is equal to 6y, so y is going to equal 1, right? All right. That is one of the hardest things for people to muster for whatever reason. It just always is. Try this one with me. This is another, just like that one. I'll try and squeeze it in. 4x minus 28 divided by 3 equals 2x. What are we going to do first? Multiply by what? Good. What is the result of the left-hand side being multiplied by 3? Okay, leaves me what? Good. And what is the result of my right-hand side multiplication? Okay, we've got numbers and letters on the left. We have letters only on the right. Easiest way to clean that up is to move your 4x, right? How will I do that? Next. What is the result? Excellent. All right. We also have scenarios where you will end up with answers that are called all or no solution. And you're going to see that here in a minute. Well, first, actually, I'm getting ahead of myself. Example 4. This one is a big bad mess. Lots of work to be done, but look for all the little things that we've done here. I'm going to show you. Let me get it set up. 12r plus 14. Okay. Look for any symbols of inclusion. Do you see any? Any parentheses, da-da-da-da. So what am I going to do with it, Lee? Say again? Okay, so what do I do here? Okay, so what's the result? 4r minus 36. Okay. Okay. It is critical that you deal with this component prior to doing anything with this. Okay, this does not happen until after that has. Can we start combining like terms? First, we'll deal with this, which is 4r minus 34 equals 12r added to 14. Now it's kind of up to you. You've got numbers and letters on both sides. What do you want to move to where? He's right. That's what I would choose as well. Not that you couldn't subtract the 12r to the left, but I happen to prefer keeping my variables positive. I now have a number on the left and numbers and variables on the right. What do I do next? Uh-huh. What do I do last? Divide by? So r is equivalent to -6. Good? Okay, examples 5 and 6. Ugh, everybody's least favorite thing. Example 5 is a scenario where the answer is no solution because what you get is false, and you're going to see why. Here we go. 3 times x added to 2 minus x is equal to 2 times x plus 1. Okay. Distribute, distribute. You won't know that it's no solution until you work it, by the way. Does everybody see how I quickly distributed? Okay. I now have 2x added to 6 equaling 2x added to 2. Where do you want to move your x's to, the left or the right? Okay, so we're going to subtract 2x. You could have gone either way. In any case, look at what I have now. 6 equals 2. Remember how I said at some point, if you encounter that something is false, you have what is called no solution? Does 6 ever equal 2? No. So right at that point, you are now at what they call no solution. People sometimes write NS, or in the back of the book, I think it might say empty set or null set, which means there is no answer that will fulfill this question. There is no number that would create a scenario where 6 is equal to 2 in the known universe. Okay? So, in a nutshell, when left equaling right is false, the answer is no solution. Okay? Last thing, I know this is long, I'm sorry. Last thing. This is a all numbers, also known as the word identity scenario. And again, you won't know that until you've solved it, but a problem has an answer of all when right is identical to left at the end of the solution. I'll show you what that looks like. 1/3 of x, wait, hold on. Nope, don't copy that, that's wrong. 2 multiplied by 3y added to 5, added to 9, equals 6, I'm squeezing it in, y plus 3 added to 1, sorry about that. Okay. Start by your normal stuff. Remember, this doesn't look any different. 6y added to 10, added to 9, equals, we're going to 6y added to 18, added to 1. Cat, keep me honest here, make sure I don't make any goofy mistakes. Can we start collecting like terms? Right here we've got 6y added to 19. And on the left we have 6y added to 19. What did I say about this? When right is identical to left, your answer is all. Right now, is right identical to left? What if I wrote it this way? 19 plus 6y equals 6y plus 19. Are they still identical? Absolutely. Just because I flippy floppy doesn't make a difference. Let's say at this stage of the game you recognized it. You can quit and you can write this. Let's say you didn't recognize it and you wanted to keep going. Let's collect all of our y's. You want to move them to the right or the left? I'm going right. 6y. They both disappear. 19 is equal to 19. Does right match left? What this literally means is that any number inputted for y will produce a truth, as in will solve the equation. And I'm going to prove it to you because I'm a magician. Pick a number between 1 and 10. You know, I don't even have to say 1 and 10, but I'm trying to keep it easy for myself. Pick a number, and I'm going to use it for y. 20? All right. 2 multiplied by 3 times 20 added to 5 plus 9 is equal to 6 multiplied by 20 added to 3 plus 1. Jay said 20. Jay's trying to throw me under the bus, thinking I'm going to make a mistake. Here we go. 2 times, was it 65? Added to 9 equals 6 times 23 added to 1. Get your calculators out. Is this 130? Folks? Okay. Say again? Uh-huh. Okay. Nice try. So anyways. So there's a huge difference, my friends, between all right is identical to left and none. Left equaling right is a falsehood. Okay?